So in this lesson, what you guys are going to be looking at is dealing with the two laws, or the first of the two laws that you guys have done in geometry class, which was the law of sines and law of cosines. Let's first review the law of sines. So the law of sines can be used to solve triangles that are not right triangles. Remember, we used SOHCAHTOA, that beautiful little mnemonic, when it came to right triangles, but when we run across triangles like these that are not right, we need some other tricks up our sleeves, and one of them is the law of sines. And the law of sines states that the sine of angle A divided by opposite A, side A, equals to sine of B divided by the side B, and equals sine C. You've seen this before. I could go on and on about that, but you've seen it. You know, sometimes you might see the law written like this. This is what I'm used to seeing, is where the sines of all the angles are on top and the sides are on the bottom. Don't be shocked. I know the textbook does do this, is they put it upside down like that. If you take a second to think about it, when you solve these things, you're going to get the exact same thing, aren't you? So there's really no difference between having the sides on top or having the angles on top with the sines of those angles. Now the other thing that does give some students some problems, I see like 3 different fractions here and they feel like they have to use all 3. Remember, you don't need to use all 3 ratios. Just use 2 out of the 3, and when you set up these 2 out of the 3, what you're going to end up having there is a situation where you're just going to cross multiply and divide. That's the excellent thing that students seem to always be successful with the law of sines, is they know how to cross multiply and divide with their eyes closed, and I bet you guys are no different. Let's see a couple problems with that. Before we do that, those 2 ways of these problems can be worked out. One is if we're trying to find a missing side, and then there's another situation where we have to find a missing angle. Remember, with missing sides, it's pretty straightforward with cross multiply and divide to getting your answer. With the other case there, finding a missing angle, just realize that your finishing move there is going to be just doing the inverse sine, which we did a lot of in 5-5. So looking at this example, suppose we knew angle A was 33 degrees, angle B was 105, and we knew that side B was 37.9. And they're asking us to solve the triangle. When we're solving, we need to find the missing information. So the missing information that we have here is C, side C, side A, and angle C. Taking a quick look here, angle C is pretty easy to get, right? Because we know that magic number with all triangles is that the 3 angles always add up to 180 degrees. So just doing a little subtraction here, we end up with 42 degrees for that angle. Now let's really flex our law of sines muscles here. So for law of sines, we have these 3 ratios here. What I like to look for with the law of sines is spot the out of these 3 fractions here. Do you see which one of these 3 fractions do they give us both the side and the angle measurement? Can you see it? Yep, right there with B and angle B. So start with that, and then from there we can really go 2 different routes. We can either find side A or we can find side C. Let's just go ahead and find side A first. So our next move here, substitute. So there we go, we put those angles in there. So notice the only unknown that we have here is A. Just keep that in mind as you keep on doing the law of sines. If you substitute stuff in there and you have multiple unknowns, you made a mistake someplace. Just remember, like I said before, if we backpedal here, the key is finding that opposite angle and opposite side that were both given to you and start from there, and usually you can work it out from there and you'll be good to go. So from here, the next move after substitution every single time with the law of sines is going to be cross multiply. So when we cross multiply here, we're going to take A, multiply it by the sine of 105, and let's take 37.9, multiply it by the sine of 33 degrees. So then we arrive here. Remember, our job is to get A by itself. So our next move to get A by itself, let's divide both sides by the sine of 105. So it'll cancel out on the left, we move it over to the right, and there it is. A is our exact answer, which you can see right here. But let's go ahead and get a decimal approximation of it. And like I said in class, be careful with your decimal approximations. Try your best to use the answer features, or you can look right here on the calculator. This is how I approached it. Just put the numerator in at once. 37.9 times the sine of 33. Boom. You got 20.6-ish. Then let's take that answer and divide it by the sine of 105. So now that we're at 21.36, blah, 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 blah. Let's approximate that. Let's take to the nearest tenth on all these folks. So we have 21.4. Alright, so now with the 21.4 there, now it's time to find C. Let's go ahead and just rinse and repeat here. Let's start this thing all over again, and now let's just eliminate the A fraction. Now let's do the same thing and use C and angle C. Do you notice I'm reusing this and I'm using B again? I'm not using A. You know the reason why I'm not using A is for that is because that with A that we had there, that 21.4, remember that was an approximation. We rounded that. With B there's really no approximating, that's exactly what it was. So we're going to get a more exact answer with C using B to get C than if we were to use A. So substitution. What's the next move? Pew, pew. Yeah, cross multiply. So when we cross multiply there, we end up here. And I think I'm missing my variable here. Look at that. Where'd my variable go? Well, trust me, there's a C right here. Let me draw that guy in there. Sorry about that. C. And so then to solve this thing here, let's divide by that sine of 105. Hey, there's C. He's back. It's a coffee break or something. Get it? Because it's C for coffee. Alright, never mind. So 37.9 times the sine of 42. Let's take that and divide it by the sine of 105. Calculator, boop, 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 boop. And there we go, 26.3. Making sense? There we go, we've just solved the triangle, giving us all the missing information. Okay, so on your note sheet you have another one there. The tricky part on these ones here is just drawing the darn thing. One thing you got to remember with drawing these, remember there's a system involved with it. So if it says angle A is 40 and B is 59 and C is 14, so what would that triangle look like? Let's go ahead and just draw any old triangle. And then we have A and B. Now, don't freak out if your angle measurements don't really match up to your drawing. You know, it's okay if your drawing's not necessarily to scale. We're playing the numbers here, not the shape, so don't worry about that. So that's what I came up with. Now we just got to label the angles on the sides. Remember, well, these ones are 40 and 59. Just remember where C needs to go. If C is 14, illustrated here, then we must put the 14 over here. And so there we have it. We put the 59 and the 40 and the 14 in there, and then once again, it's all about the law of sines to go from there. Okay?